start?
I think if you're ready,
Oh, yeah. It's good. I think we gave them extra minutes to
sounds good.
make the time. All right. Hello, everybody. Welcome. Thank you for coming to opening GradTrack workshop. And let me introduce our facilitator. Okay, fine. I don't need to be on camera. Today, Dr. Gary Burns. He's a professor of psychology. And without further ado, please take it away.
Thanks, Petra. I appreciate it. First, thanks for having me over. As Petra introduced, I'm Gary Burns. I'm actually a brand new faculty member here at FIT. You guys can feel free to call me Dr. Burns or Gary if you have any questions as we go through. The one thing I don't really like is Mr. Burns, and some people are like, well, that's because you work so hard to get your PhD, right? And no, that's an evil villain on The Simpsons, and so I tend to avoid that. One of the things that Nancy had put in the flyer, because she was kind enough to put together a lot of the information for me, because I might have been a tad bit slow on getting back to her, was a little bit about students being afraid about statistics. And I've been teaching statistics now for about 14 years, and I get that a lot. Students are, they don't take my class because they want to. It's not, I do offer some elective stats classes, but even then it's their advisors who are shoving them into those classes. And really, I think that one of the main things that students are struggling with is, what I would encourage you to think about, statistics is a language. We were just talking about R and kind of being in that R mindset. It's a very specific language, and the more you talk about it, the more you use it, the easier it's going to be, the more accessible it's going to be. So I strongly encourage you to kind of think about it that way. So some of the things I'm going to hit today, and I'm going to keep this at a rather low level, but if there's specific questions, I'm happy to address those. And let me also add that I am not a statistician, I'm a psychologist. My focus with statistics is really in terms of using statistics to answer questions. I love them for that fact. It's not the statistics themselves that I'm in love with. So we're going to talk a little bit about interpreting statistics, putting them into context, resources that's available to you to help you kind of get started with statistics, kind of depending upon where you're at, what you're looking for. And then I'm also told Nancy I'm going to talk about board games in here, and I'll probably not do that in that order. So why do you want to get started in statistics? And there's several different reasons that people come to this. We see a huge increase right now in the data science and data analytic fields. There's lots of jobs opening up in those, and those are nice paying jobs. Maybe we just want to be better consumers of world news and political information that's coming out to us so that we can interpret that better and understand what's really happening. Maybe we're here because we're in a class, and we're worried about that. Or alternatively, you're working on your dissertation process or some other major research process, and you've not taken a stats class for a few years, and now it's time that you have to dive back into that. So when I think about statistics, I like to think about it in terms of three different things I'm trying to get out of statistics. I want to organize data, I want to summarize that data, and I want to interpret it. For me, a lot of times, when it comes to thinking about statistics and organizing, summarizing, and interpreting, I'm focused on board games. I use it in my research all the time too. One of the apps I have on my phone is a program called Board Game Stats. And so as I go different places and as I'm playing board games, I can just enter the information. What game did I play? Who was I playing with? And it tracks kind of all that information. So I thought I would open up with just a couple questions from the stats I've been tracking through that app. I also put a call out on Facebook to a couple of the groups I'm in and said, hey, you guys who also have this program, why don't you share some of your data with me, and I'll use it for this presentation. So the first thing I had up here is how many people do I tend to play board games with as I go through, and you can see about 75% falls into those three broad categories. 4 players, 2 players, or all by myself in terms of it. And I can almost guarantee you that this is entirely my family that we're looking at here. My 2 children and my wife, when I can get them to play a game with me, oftentimes it's just one of them because they've got homework or some other activity that they're engaging in. Or alternatively, I'm a big fan of solo gaming, and so I've got a number of different games that I'll play by myself. That little tiny yellow sliver is like 8 players, and that's the smallest category that I've got kind of up there. I mentioned I'm a new faculty member, and so one of the things I was curious about, did moving to Florida interrupt my board gaming playing schedule? And so, right around here was when I interviewed, and this May the 7th, we played a lot of games. I had a bunch of graduate students over.
Yes.
Okay. I had a...
It's touchy.
I'm a very touchy person, so I apologize. I'll try to keep my distance from it. I had a lot of graduate students over that night, and I knew the very next day I was flying down here to give an interview, and so that was an especially awkward board gaming session. Where I got the job offer was right here in the beginning of June, and suddenly I had to sell my house in the next month and had to clean everything out. And you can see that everything just kind of swept aside until I got down here. I actually had a couple games in the car with me that we could play like on the road, but not too often. I got down here and it still hasn't really picked up at this point in time. Enough about me. I want to ask some questions here and kind of get some feedback. So some of the information I got from people. So Paige and Mindy. Mindy's not Anthony Bourdain, unfortunately, who passed away. But they gave me these screenshots of how many games they've played this last year. And so one of the questions I wanted to ask you guys was, who plays more games, Paige or Mindy?
Oh, sorry.
Yeah, go ahead.
No, who plays more games?
Yeah.
Your bottom one, I guess, said games number is there.
So Mindy down there plays more games? Because she's played 119 different games. You guys agree with that?
I'd say it depends on what you mean.
Oh.
Plays more games as in times, or plays more types of games?
Yeah, because Paige up there,
I see, yeah.
who was not at all happy with the idea of me using her profile picture for this, she's played 234 different games, and I was really fascinated that both of them have spent about 111 hours, in terms of tracking this. But that's a good question. What do I mean by this? And I don't have an answer for you. So what's Melanie's favorite game? So Melanie sent me like this lovely little screenshot showing her last game played and her statistics, over the last 365 days. What's her favorite game? What do you think, Martin?
Roll for it.
Roll for it? You guys agree? Why do you think that's her favorite game? This tells us nothing about her favorite game. This just tells her what game she plays the most often. And so I want you to get that wrong. Thank you, Martin. I appreciate you taking that in. Why does Scott spend so much more time playing Dominoes than his other games? And Scott was actually a little offended by this slide when I showed it to him and said, this is the one I'm going to use from you. But why does he spend so much more time playing Dominoes? And if you look at it, I would say about 4 times as much he's playing Dominoes than the other games, right? Any concerns?
Maybe it's just the people he's playing with like Dominoes and he's accommodating them.
Might be that, and if you look at this bottom number right here, that's 6 hours versus 10 hours.
4 hours.
So we're actually looking at just a 3-hour difference between these 3 games. So I'm not sure that's really all that much. He had another game that he spent like 35 hours playing, and I left that one out because it skewed the data too much. Let's talk about something that matters. I mean, right here I'm just talking about people's preferences. I need to decide which board game to buy next. So I've got 3 up here that I've kind of taken. If you go to Board Game Geek, it's an amazing website. They give you all the statistics for people who enter in this information. They provide their plays, they provide their ratings. So I pulled up 4 different games that I'm thinking about getting. The rating scale is from 1 to 10. What game should I get next?
Twilight or Pandemic?
Twilight or Pandemic? I agree with you on one of those 2.
I'd say Pandemic.
Yeah. Why not this Deep Madness? It has like a perfect 10.
2 votes.
Yeah, two votes. Incredibly unstable. I mean, if I want a solid choice, that Pandemic at 27,000 people rating that, I mean, that's, that's a lot of people saying, hey, we like this game.
Well, I gave those 3,800 a pretty heavy weight because it's less time, because it's 2017 versus 2015. You have more time in there to spread out the votes.
True, true. Yeah, my wife actually weighed on this one, and she said the correct option was none of the above. So she wanted to make sure that I made that clear to everyone, so I'm kind of locked in. She doesn't know this one's actually pre-ordered. So some of the lessons from this board games, as we're kind of looking at it, as we're thinking about, looking at data, looking at statistics, we need to be specific with the questions that we're asking. So, when I asked, you guys correctly identified it, who plays the most games? So what do you mean by that? Do you mean the actual number of games, or do you mean the number of plays that we're recording within that? Make sure that the data can answer our questions. So, I asked what was the favorite game, and none of that data I provided was about favorites, which one they liked the best. It was all just frequency counts about who they play. Maybe, Melanie's husband won't play anything else than Roll For It. So that's her go-to game in the family. We need to be careful not to misinterpret or misrepresent the data. Especially since, if we're graphing something in Excel, a lot of times it'll automatically set that y-axis for us as we're going through. And that figure I had up, I actually set that to try and mislead you. But we need to be careful with that. And then finally, remember the limitations of our data that we have and what it can actually tell us and what it can't tell us. And as humans, we want to draw inferences, we want to interpret things, and so we have to be careful, how far we kind of take that natural tendency. And we'll come back to some of these a little later on. So back to this kind of purpose of statistics that I said, organizing data, summarizing data, and helping us interpret data. I also want to give you a slightly different view. Microsoft has an amazing video. Martin, do you know if the slides will be available as well in addition to the video?
Yeah.
Okay, excellent. So what I've done is I've tried to link everything through here, so if you want to get a copy of these, you can, but Microsoft has a great video where they walk through and they talk about 5 different questions that you can answer with data, kind of from that interpretation point of view. So this first one, is this A or B? Just a dichotomous classification, if we're trying to determine, what works better if we're trying to bring in customers. A $5 off coupon or a 25% off coupon. It'll help us determine, which one is this, A or B. Is this weird? And this is actually what most of our statistics start telling us. If we accept that null hypothesis, is this weird? Does this stand out in some other way? How much or how many? So a lot of times we're working with regression techniques. So I mentioned I'm a psychologist, and my actual area of specialization is industrial and organizational psychology, and I focus a lot on organizations and helping them employ people. So I develop a lot of different tests. And what we're trying to do is we're trying to use those tests to predict that worker's performance. Maybe it's how many widgets they're going to produce on the job. Maybe it's how likely are they to engage in counterproductive, deviant behaviors in the workplace. And so we're trying to predict those things. Questions 4 and 5 start getting into the more complex types of questions that we can answer with statistics. So how's this organized? If you guys use Pandora or Netflix or something like that, and it recommends, you might like this song, you might like this movie. That's really what we're looking at there within those algorithms. So looking at how data is clustered, looking at how information is situated, and trying to determine, what is it that you like. If you like this book, what might be another book that you like to have? And so there's a number of companies that are just making their living purely, on these types of algorithms. And then this final one, what should I do now? This is really getting into the AI research that's going on in terms of helping, using statistics to determine, if I am a little robot vacuum cleaner running around your house, when should I go back to that charging station versus, should I try to clean it a little bit more at this point in time? If we're an automated car and I'm sensing something with my radar coming through the bushes, should I stop now or should I speed up and try to get ahead of it? So these are the things that we're kind of looking at with this last question of, what should I do now? And again, a great video, I highly recommend kind of checking it out. So what I wanted to do was just kind of give, again, a kind of a low-level view of thinking about, getting started with statistics and what you should do kind of next. One thing that should be clear is you should think about getting that board game stats app and adding that to your phone and playing some board games, tracking it. I'll give some tips about that later on. But the big thing is learning about data. Learn about the different types of data that you're going to be working with, that you're going to be encounter, and we're talking a little bit more about that. Understanding sampling errors and corresponding standard errors. One of the things to keep in mind is that statistics is all about uncertainty. We need to understand that uncertainty. We need to understand the error that's built into the statistics that we're using, and that's going to be represented usually in terms of the sampling error, standard error. Get a grasp of statistical significance, which I actually won't really touch on today in this talk. And then originally I'd written know what statistical test to use. And this is what I want my students to do, is I want them to know all these different tests, and given a specific problem, which test should they bust out, which analysis option should they be choosing in SPSS, or which programs or packages should they be loading in R to answer that question. But very much the world is changing, and we don't need to actually know that information. What we need to be able to do is we need to be able to search out that information, especially as people are developing new statistics, as they're developing new functions for us to use. We need to become savvy in the way of finding that information and knowing what's a multiple test that's available to us, and determining what's the best option that we have available for us. So I want to kind of keep that simple as I try to talk about those things. So as I set up into kind of three broad areas. What do we want to know about? What's the type of data that we have? And then how's our data structured? And I want to touch on these three things kind of briefly. Keep in mind that this is a very broad level overview. And I'm going to simplify some things, and anytime that we simplify something, we're creating gray areas for things that don't naturally fit into those nice tight boundaries that we want to create. So the first thing I want to bring up in terms of what do we want to know about is, are we concerned about samples, or are we concerned about a population? So are we interested in descriptive statistics or inferential statistics? We usually talk about descriptive statistics as describing the sample that we've drawn, and in our textbooks that we look at, they're usually represented by English letters. We're seeing, so our mean, APA recommends that we now use M to represent that, our standard deviation, SD. Again, there's several times that we might just be interested in that sample. If I'm working with one specific company and they're my client, I want to describe that sample. I want to focus on what's happening in there. I want to really understand what's happening within this specific data set. I'm not necessarily concerned about generalizing it to other organizations. I just want to describe this data. That's what I'm being paid to do. Now, as a scientist, that's not what I'm doing most of the time. And even when I'm being paid to focus on it, I'm often thinking ahead, because there's lots of other organizations just like that company that's paying me. And what I want to be able to do is use inferential statistics to make inferences about those sample statistics to those population parameters. And so you know that you're talking about population parameters if you start seeing Greek letters as you're looking through your stats book, so such as mu and sigma. That's usually be your big indicator. So real quick about kind of sampling error and standard error. And this is what's going to come up as we talk about inferential statistics. Because remember, with inferential statistics, we're making inferences. So we are making inferences about our sample to that population in which we draw it from. And any time that we engage in research, we're going to be making errors. This guy over here on the left, he's suggesting that maybe we haven't selected the best person to be asking about this situation. But most of the time, even if we do a great job of sampling, we're going to have just random error in our data. What this random error is going to lead is to this, we refer to it as sampling error, and that gives us this information about standard deviation. So standard error, is a way of thinking about how far off are we usually when we're making these types of predictions. And so I thought this right figure was great to kind of represent standard error, because we've got this person who goes around baking these things that they've seen on TV or in websites, and then here's what they produced as the result of this. And so yes, it is a football cake, Kind of, but it's deviating from that population norm that's being represented. And that's what we're talking about with our standard errors, though hopefully it's prettier than what we're being presented with here. Types of data, and I want to touch on this just really briefly. There's lots of different ways of classifying data and thinking about data that's out there. The more complex systems will have like 25 different categories. And again, as we get into these simpler methods that are easier for us to remember, we sometimes create those gray areas. But within this, the type of data, the system I always teach my students, I encourage them to think about is this, I can't say it, what's the French word? Noir.
Oh, the simplified
Noir?
acronym?
Is it Noir?
Noir.
Is that how you pronounce it?
Noir, yeah, let's go.
Noir. So a fantastic category of films. If you've not seen Sunset Boulevard, that's a great movie. I highly recommend that you check that out. But beyond being a fantastic French word, it's a great organization, and it puts it in order of more complexity with the data that we're looking at. So if we're talking about nominal data, what's nominal data?
Name only.
So name only, these are categories. So there's no natural ordering of it. So it might be male, female, it might be red, blue, pink. We have categories that are mutually exclusive that we're assigning values to, and those values are completely arbitrary. Then we get a little more complex as we move into ordinal. That's where we start adding rank order information. So now we know who's first, who's second, who's third. I got in a race, I finished up a race the other day. I'm kind of looking forward to the FIT 5K. I came in third. How did, what?
Had 3 people?
Yeah. And even if we did have 3 people, we still don't know anything about how I did beyond I was the third person. I could have came in like 20 minutes after that, and my great-grandfather might have been 2 hours later after me. And so, all we're getting is ordered information. In psychology, this is kind of problematic for us because most of our data is ordinal that we're working with. Such, for example, if we're working with intelligence data. We like to pretend that that's nice interval level data, but really all we know from an IQ of 101 versus IQ of 100 is that 101 is a higher score than the 100. Where we can really get into the rich statistics are these next 2 categories, our interval level data and our ratio level data. And remember, we're continuing to increase in complexity. So with interval, we're keeping our rank order information, but what are we gaining?
Timings, locations, short
The location is set. So when we have the interval data, we know that the location is set. We have equal intervals between all of our data points. So if we're talking about the distance between 101 and 102, we know that that gap is the same. With our ordinal data, all we know is that 102 is higher than 101, which is higher than 100, but we don't know about what those gaps are. With interval level data, we know exactly what those gaps are and that those gaps are constant. And then finally, this last one is this ratio level data, and what we're getting there is a true 0. Because under our interval level scale, our 0 is an arbitrary value, and so we can't make comments like 4 is twice as big as 2. Or if we think about it in terms of temperature, is 60 degrees twice as hot as 30 degrees? Yeah, so we can't make those comparisons unless we have that ratio level data with a true 0, and then we can move forward. And this is going to impact what statistics that you can use. So for example, with our interval and ratio level data, that's where we can start really using our means and standard deviations. Because those decimals that we're going to be getting are now meaningful to us. We know what a 2.5 means. That's exactly in the middle between a 2 and a 3. On an ordinal scale, if we get a 2.5, we actually don't know what that means. We know that somewhere between a 2 and 3 is in the middle. Is it closer to 2? Is it closer to 3? We don't know because we don't know the distance that's in there. The deep shame in psychology is that we will often treat this ordinal data as if it was interval and ratio, and there's some justification for it. not great justification, but there is some justification for it, because again, we're getting into those kind of gray areas where we've simplified lots of values down into just these 4 categories. Questions before I go on? Comments, concerns?
So which of these would be used more for predictive data?
Oftentimes, it depends upon what we're talking about. If we're talking about engineers working with predictive data, we're talking about a lot of times ratio level, because we've got true zeros.
Right.
I'm sometimes surprised, I use a lot of the same statistics that engineers do, and we'll talk about our different data sets, and I'll be really happy. I'll be like, I can explain 12% of the variance in employee deviance. And then they start laughing, because they can explain 99.97% of their variance in their studies. I think about it, and I'm actually really happy. That's awesome, because I don't want my bridges to collapse as I'm driving across them.
So I'm assuming the ordinal data would give you predictive data for larger number sets, so it's not as precise, so it's a generalization over a larger data set.
Sometimes in terms of that, sometimes it's the variables that we're trying to measure. So as soon as we start getting into measuring a lot of human characteristics, then we find ourselves in that ordinal component. If we're keeping, like, say, reaction times or something like that, again, we've got that nice ratio level data. If I'm asking you about what behaviors you tend to engage in, trying to predict whether or not you're going to come to work on time, suddenly now I'm working with an ordinal scale. Anything else I can address? Okay. So talking about how the data is structured, and again, I've kept this, potentially oversimplified, but this is a good categorization for catching most of our, inferential statistics questions that we have. So 3 things I'm going to talk about. So having one group of objects with 1 score per object. So most of the time for me, it's going to be participants, and those participants have a single score. But again, it could be objects. These could be characteristics of phones, and I have a rating of those phones. Having one group of objects with 2 or more variables measured for each object. So if we stay with that phone example, now I've got 2 scores that's associated with those phones. Maybe I've recorded, is it Apple or not Apple, and I've recorded usability ratings. And then this 3rd one is 2 or more groups of objects with the same variables measured. So again, I'm just going to briefly touch on these different categories and some of the test statistics that are associated with them. If there's questions, if there's test statistics that you guys would like me to talk about, I'd be happy to try to. So this first group, one group of objects with 1 score. Oftentimes, all we're trying to do with this type of data structure is to describe something. We're working with very simple descriptive statistics to describe that one set of scores. So if we have that interval or ratio level data, we might be working with means, median, and mode. And we can get into those mode with any of those categories, actually, from our NOR system. Or if we're working on that nominal, we might be focusing purely upon frequencies within that information. So again, really with just 1 score, we're trying to describe that sample. Some of the inferential statistic questions that we might want to ask about: is this sample different from a known population value? So, a great example of this is, maybe a phone company is testing out a new smartphone. They know the usability ratings. They have ratings about how people like that previous phone. They send this new phone out, they collect that information, and they want to know, is this set of ratings associated with this new phone different from that population value, that information that we have? And so they can conduct a 1 sample t-test in order to determine, does this likely represent something different than what we actually already have? And that's the big thing that we're getting with that 1 sample t-test. Is this different than what we already know? Second one I've got up here, so do these frequencies adhere to uniform distribution, or do they follow a normal curve distribution? That might be something that we're trying to ask. So maybe we've got categories of people indicating, what color is their preference, and we want to know if those color preferences are uniformly distributed. So I can use a chi-square goodness of fit test to evaluate that component. Alternatively, I might be collecting, ratings about the favorability of some political issue that I have, and I don't think that's going to be, uniformly distributed. I think most people are probably going to fall in the middle, and I want to test those assumptions that most of my scores are in the middle and fewer are on those extremes. So then I can test that using this chi-square goodness of fit test statistic as well. But we're really limited if we just have the one score that's associated with one group. We get one group of objects with two or more variables. There we can really start looking into relationships. And so there we're going to have the same descriptive statistics I mentioned previously, and we can add a couple to this mix as well, correlation coefficients and regression coefficients to describe the relationships between variables. Usually we're going to be working with the Pearson correlation coefficient and assuming a linear relationship, but there's lots of other options that's out there for us. The example questions I wanted to talk about here. So does the distribution of frequencies depend on the level of another variable? So this chi-square test of independence. So we were talking about the chi-square goodness of fit test, with the one component. There we're just looking at the distribution of frequencies to see if it meets like what we've specified. Now what we can do, because we have two different variables, we can look to see if that distribution of frequencies is the same across the level of another variable. So for example, we might ask people to rate how happy are they with their different phones, and we've classified those phones as being either Android or Apple phones. And we can look at whether or not the distribution of those ratings, the proportions, match up between those two phones, or if those proportions are different. We can predict the value of one variable from another variable. So I mentioned in I/O, oftentimes what I want to do is I want to predict the number of widgets that a worker can produce. And so I've developed a very specific, say, IQ test or something. I've gone through, I've measured all the workers on that. I've got information from their managers about their levels of productivity. So I've got that one group, those two different variables, and now I can use or create a regression line and a regression equation that I can predict the number of widgets that they're producing from what their intelligence was. And then the third example I give here is for this point biserial correlation coefficient, which is going to jump right into our next slide as well. Are these numerical scores related to a dichotomous variable? And so this is a very specific type of correlation coefficient where you have one dichotomous variable and one numerical variable. And so for example, if we had those iPhone ratings and the Android phone ratings, so we might classify them as 0 and 1 depending upon the phone type, and then their likability on the other one, and I can run this point biserial correlation coefficient to determine, is there a relationship? Do people prefer one phone over the other in terms of this correlation coefficient? I'm going to use that same example in just a moment, but questions, anything else I can kind of address at this point? I'm going to jump to this third group. So having two or more groups of objects with the same variables measured. So now we can describe and evaluate differences between groups of scores. So we're getting more complex. We've got multiple variables, and we have multiple groups. So we can do things a little bit differently. This first example I'm giving is actually the same as what we were just kind of talking about. I had to fight really hard not to touch it there. So are two groups different from each other? I said with our point biserial correlation, we could have a dichotomous variable and a numerical variable and look at the relationship between those two things. Alternatively, I could calculate the means for the Android phones and the means for the Apple phones and compare them using an independent measures t-test. And so again, it's just a slightly different way. In the one side, I said, that group membership, that's just a variable. So I have one group with two variables. Here I'm saying, no, that's actually two different groups. So there's lots of different ways that we can think about our data that highlights those kind of gray areas I was talking about before. Something else I might be interested in, did two groups develop differently over time? So I might be interested in tracking college students. And maybe engineer majors versus educational majors, and tracking them across some variable. And so I could use a repeated measures Anova to determine, did those groups actually change over that period of time, and was that rate of change different between one group and the other group? And then the last one I had up here, I wanted to make sure I jump back to some non-parametric statistics for when we're working with some of those nominal and ordinal level data. So this one is the rank order of one group different than the rank order of another group. So, I used the race example with me coming in third earlier. If I had everyone in this room run through a race and I ordered it up, I could examine, well, are the females in the room faster than the males in the room, just based upon that rank order information. Personally, I would like to know how much time did you finish in, because that's richer information, and I can convert that time back to an ordinal level, who was first, who was last. But I can never go the other way around. If I just have that ordinal level data, I can't convert it into that richer interval level data in terms of how much time. So I always encourage all my students to think about, what's the richest data set that you can get, because we can't always go backwards in terms of the complexity of our data. We can't go forwards with it. So again, 2 or more groups with objects of the same variable. When I originally put this together, I think it was like 8 slides with like 8 bullet points each talking about different statistical tests. And I'm like, I don't want to present that. So I tried to just kind of touch on a sampling, but is there anything that you guys are here hoping to hear about? And if not, I got some very specific tools I'm going to recommend to you in a moment.
So I'm assuming in this subject, if you had, for instance, a military test of equipment, and you're testing 2 groups, one with the equipment, one without the same variables, you'd then get some correlation of what the equipment's doing as far as the rank ratings.
Yeah, and then in that case, again, I could picture it 2 different ways. I could think about it this way and run it as an independent t-test, independent measures t-test, as I got those 2 different groups, one with equipment, one without. Or I could code that group membership as a 0 or 1 and run that point by serial correlation to represent it as a correlation coefficient. Yeah, but in both ways, I'm going to get the exact same information and draw the exact same conclusion, but it depends upon how I want to present that information. What's the story that I'm trying to tell? What's my audience sometimes too? So I promised, and again, I've got some good links up here for you. Lots of tools are available to you online in terms of helping you identify what's the appropriate statistical test that you should use for a given situation. So in this one, the question our hypothesis proposes, are we looking at an association or relationship between 2 sets of scores? Or are we looking at the differences, comparing 2 or more different groups? So let's say that we've got our 2 different groups. We're interested in that military equipment situation. We got one group with, one group that's without. Is the level of the outcome dependent variable, is it continuous or categorical? So if we've just been very simple, we've asked people, did they do a good job or not? If that's all the data that we have, then we have a categorical dependent variable, and we can just run our chi-square test, and specifically our phi coefficient, if we want, as a correlation coefficient, to represent the relationship between that. Now, if we can get more rich data, maybe actually we can look at how much time it took them, how many of their objectives did they actually meet. So now I'm looking at this continuous data, and is the outcome normally distributed in the population? So a lot of times, if we look at performance within an individual group, we will see some of those normal distributions. I can calculate the means. Are there more than 2 means? No, we said that we just had the 2 groups. The 2 means represent independent samples or paired or matched samples. In this case, we have our independent samples, so we end up with our t-test for independent samples. Now, if we had sent the same people out there and had them complete it both with or without the equipment, then we would be matched. Or if we were lucky enough to find a bunch of twins in the military and send one set of twins with the equipment and one set of twins without the equipment, we could use this t-test for, they both say independent samples. Those are supposed to be dependent samples within that component. Sometimes these tools are not right. There's also a number of ones if you're looking for something more advanced. So this is a blog that I really like in terms of machine learning, and it focuses on a lot of different R packages related to machine learning. I find machine learning to be kind of a funny term because a lot of times I think of them as just regression techniques that we're using, but it's a big umbrella term. And this guy's got I think it's like 7 or 8 different of these tables to help you determine what machine learning algorithm should you be focusing on depending upon your question. So here and I tried to blow it up as high as I could, but so this first one is, should I replace this part now? So we're looking at some type of predictive maintenance issue. And it says, the first choice is the 2-class classification. If we go back to that Microsoft question, is this A or B? Should this be changed now or can it wait? When will this part fail? That's where we should be using some type of regression technique. So what information do we have about that part? How old is it? How many miles have been put on the vehicle? How does the person drive? And using that data in a regression formula to help us predict, okay, how many more miles can we get out of this, or how much more use can we get out of this tool before it is likely to break? And then depending upon what our thresholds for error are, if the result of making a mistake is very minor, I'm not going to be too concerned. I'm going to keep in mind, this is probably going to fail soon. However, if we're talking about, jet engine maintenance or something like that, I'm probably going to want to take that estimate and be a little more conservative. I don't want to waste money, but I certainly don't want the engine to blow as I'm up in the air. And then there's lots of fun comics that's associated with this as well. So I use a lot of regression, so this one really stood out for me. If you guys aren't familiar with it, this XKCD is a fantastic comic. They describe themselves as a webcomic of romance, sarcasm, math, and language. And there he's just talking about some different types of regression coefficients we can actually calculate. And he's being funny, but it's actually all right information as well. So as we start getting into polynomial regression, so our linear regression is just going to give us a straight line. But as we start getting into our quadratic regression, we can start creating figures using math, or we can start creating curves using math. Specifically, we just square those terms. Our logarithmic, exponential is just ways of distributing and changing our data to represent these lines. So I really like this because again, it's accurate, but it's trying to be funny. Okay, so kind of talking about those questions, I wanted to touch base real quick about some common data analysis software and some resources that's available to you. I can talk about specifics if you guys want. What I'm most familiar with is SPSS and R, but there's lots of different tools that's available. Excel and the add-ons that you can add into Excel now actually are pretty fantastic. Someone was telling me that and I didn't believe them. And then they showed me, and it's actually, this is not that bad. SPSS, is a program that most of my students use in the psychology program. We have SPSS here in the library as well, and that's why I put this nice little picture of Evan's library for us, because you have access to these programs here. SPSS by itself is very expensive if you're purchasing it yourself. If you're using a leasing option, you're looking at, I think it's around $100 a year. Oh, go back. Or something along those lines. If you're looking for something on your own computer, that is, you want something free, and I forget if it's Dutch or where, I think it's Dutch, they developed this JASP. And what they wanted was kind of a free open source alternative to SPSS. So it's a similar kind of point and click program where you still have the different interfaces. It looks very similar to SPSS. It's just not as well developed since it's not IBM pouring thousands of dollars into it. And then R. And I love R. It's taken me a really long time to get to this point of loving R. It's been a hate-love relationship. Hate more often than love as I go through it. But one thing I really like about it is that it's platform independent. So I have it both on my Mac and on my Windows program. And since I have everything, my database is stored in the cloud, I can just easily pull up the same files and I don't have to do anything special going back and forth between them. Consistently in the top programs, languages identified by the IEE, so our Electrical Engineers and Electricians Guild. Data scientists report Python and R are the most common programs that they use. Python's #1, R is actually number 3 on the list, but then when you follow up, what's the next program they use? They say R. So I'm not sure why it was bumped to 3 on that. And then the survey of, I think it was like 31,000 technology professionals, they named R as the number 1 highest paying skill. I'm not sure I agree. I think that there's still a really strong movement within the Python, but I have to admit I don't know Python personally, and so I'm happy with R. And since it was R, I had to get a pirate joke in here. And this also comes back to board games, because Get Your Fun On is your local board game store here in Melbourne. And on Thursday nights, actually, they stay open to like something like 2 o'clock if you want to go play board games in their common room, and they have like a number of board games that you can grab. It's funny, I don't have a doctor yet, but I have found a board game store that I like. A couple things to note about R, kind of staying on it. So R was designed by statisticians. So it was developed very purposely by statisticians and used by statisticians. It's freely available. Rob and I were talking earlier about RStudio, which makes it so much easier to use and to organize your data. The Shiny is an amazing application if you want to build that into a website for visualizing data. Several of you have probably used some of these functions if you've gone to a website and you've maybe selected, different nationalities or different states, and it's showing you the way that data is being organized. And then the R packages, these are actually developed by users. You have a very specific need. R doesn't currently do it, or maybe it doesn't do it very efficiently. So you develop and write out the program yourself, and you can put it in the CRAN one. When I left Wright State University, Joe Hoft is the gentleman over there on the right, and he is a monsterly tall individual. I've always been kind of self-conscious of my height, just being under 6 foot, but when Joe's around, it just blew me away. But he has this SFT program, so Functions for System Factorial Technology Analysis of Data. You can go to the CRAN website, or in R you can just specify library, or I think it's load package, and then specify SFT. It'll automatically bring it in, and then you can load it using the library function SFT. So it's amazing the number of packages that's available to you, and the complexity that's already out there. But I do put a warning, it does have a steep learning curve. It's not an easy route to go, which leads me to some different resources for if you want to get started with R. And again, if you're thinking about data science, I highly recommend. Though it's a steep learning curve, the number of things that you can do in one program is amazing. Before R, I was always jumping back and forth between SPSS, M+, and a couple other programs. Now I can do it all in R. DataCamp is something that I really like. I don't like it that they get you hooked with some free programs. You're learning the basics of it, and you're like, yeah, this is going good, and then suddenly it's like, oh, that's the end of your free stuff. If you want the rest of it now, you have to pay. But what you can do is you can beg and control your professors to start a class, and if they start a class, up to 10 people can join on that class and get access to all their paid programs for 6 months. Then after that, they want to start charging you again, but 6 months access to it. I didn't realize it was limited to 10, so I invited like 30 people to join my art class, and then there was a lot of sore feelings once we discovered that hard limitation. Rob is a thing I want to talk about in terms of a local one. So as I was going through, I was looking online, and it's like, oh wow, they have an introduction to R workshop. We just missed it. But
So did a lot of people.
But in terms of having it set up and having those resources here, I know when Nancy was asking me to do this, she's like, we could probably even send someone to come to your class and give a little workshop on R. I'm guessing that was either you or Haley who's the other person?
Was that?
Is it Haley who's the other person or is it just you who does R?
Pretty much just me.
Just you? Yeah, so she was completely offering you up. Other campus resources, so again, R has a steep learning curve. You may be like, no, that's not for me. I just need to finish this graduate project so that I can get out of here. SPSS or using even Excel. So what are some different resources that's available to you? And so kind of a shout out to Martin and the DSL component here. I was really surprised, looking through it, we had data analysis, data curation, data management, in terms of services that's being offered, people that you can talk to right here. And then there's Rob being mentioned again in terms of this component. But so right here in the Evans Library, you have those resources available to you. I also talked to Dr. Goldfarb at the Math Advancement Center. I said, when I was hired, that you guys sent someone over to talk about the Math Advancement Center. They talked about students coming in for math class tutoring. Like, what if I've got stat students who just want to come and talk to people about running analyses? And he said, that's great. Send them on over. He did mention that, if they're really busy, they have to take care of the math students first, and so you might be a second priority on that. But then I looked at their schedule for next week, and so the green ones are open things if you want to schedule time to talk with someone about statistics. And then these are all the classes that they say that they provide tutoring for. So if you're dealing with a statistics issue, if you're working with probability components, most likely someone over there can help you and talk to you about your project. And he said that he was very good with me giving that plug and kind of talking about that, so I'd highly recommend take them up on that. And then the last thing I had was I had this list of names. Who do you guys think these are? Yeah, these are professors. So I just went into the course schedule and I typed in STAT. And these are all the names that come up. These are the professors that you have on campus who are teaching stats classes. In fact, there's probably more of them because there's probably classes that's called like advanced probabilities, and that doesn't have statistics in its title. And so I didn't capture those. But again, these are all the names that I grabbed across all of our different programs. You guys are here now, you've met me. Those of you that are watching the video, you've not met me, but you've seen me, so feel free, contact me. Gary Burns at gburns@FIT, and I'd be happy to talk with you about issues. And then just finally, a thanks, and I included all the links here as well that I kind of hit at different points throughout the slides. The ones that I would highly recommend is the R and the data camp again. In terms of the GradTrack program, Math Advancement, and the DSL, you have those links. Your local gaming shop, go check it out. Again, up until like 2 o'clock tonight. That's like ridiculously late. And they have like 100 board games. And it's like 100 board games just sitting there in a big room you can go play them in. And then my wife, who has been like helping support me over the last week, not just with my hobby of board games, and I think I drove to like, was it St. Paul that's north of us, or is it St. John?
St. John.
Yeah, St. John. Like
St. John.
a game came up and it was like the Marvel Legendary game, and it was like $25 that usually retails for like $65. And I'm like, I'm gonna drive up to St. John. She's like, you're gonna get murdered. But I did not, so it's all good. So thank you guys very much. I appreciate it. I went a little longer than I intended to, but I'm happy to take questions or talk to people as required. Thank you.